Hey, like Nicole, I'm excited for the next few days, and I appreciate how online meetings like this can bring people together, although I am looking forward to a time when we'll be meeting more in person. The sessions coming up outline what I think is an emerging science, adaptation science, which pulls together social science, ecology, climate science in a Earth systems actionable science framework, looking at vulnerabilities and solutions, which is our theme this week, to help natural systems and the human communities that depend on them navigate a changing environment. And as Nicole mentioned, a key element of this is the nexus between research and practice, each informing the other. I really appreciated the opportunity to work here at the center with a diverse and dedicated group of professionals, including the consortium, the agencies, different communities across this unique region, mountains, deserts, and grasslands, place that I've lived in since the 1970s, because I just had to get out of Florida. That's just, let me be honest, and dry out here in the North Central. And I think you'll get a flavor for the issues of the climate, communities, how we think about adaptation from our keynote speakers. And later, as the week progresses, we'll have other panels. We'll take up problems like wildfire, drought, ecological transformation. And if you've signed up for them, there's a few classes we can all take to get some training in data, climate data analysis. I'm looking forward to all of that. So get your Zoom settings comfortable for the next hour. I'll introduce our keynote speakers and then save your questions for a Q&A afterwards. And let me first welcome Doug Kluck. He's the Climate Services Director for NOAA's National Center for Environmental Information, NCEI, for the region. And he's going to take a look at the recent climate variations, drought, and give us an outline of what's going on in our region. Doug, can I invite you to share your screen, unmute? I know Doug's here.
I'm working on it.
Yeah, all right. Yeah, take your time. This is the moment where you might be sitting in the back of the room, and you would come up to the front, and we would get the screen going. So,
well, while I'm getting it all up, I want to say thanks for inviting me. I appreciate what you're doing here, and I'm starting halfway through my presentation, so I'm going to go up to the beginning. Let's see if that works. Okay. Do you see it, first of all? What do you see?
Yeah, we see it, and you've also got your thumbnail showing, if that is okay with you.
Is that full screen or half screen?
Now you're in presentation mode. Looks great.
Okay, well, hey, thanks for inviting me. I think I know many of you. Hi, James and Mike and Heather and Stefan and golly, all you folks, Bill. Nice to hear you, nice to see you. And, I'm going to talk a few things that are very sort of specific to the National Centers for Environmental Information, and that are kind of new, but get updated every once in a while. So this thing about new normals, I think it's going to be sort of interesting to see, well, first of all, what we mean by that, and then secondly, how the climate has changed over the last century plus, really. Then I'm going to talk a little bit about disasters and sort of extreme events. Now, there's so many different directions I could go with this, and there's so much data that could be translated to you folks. I just picked one direction, and I have a little teeny bit about current conditions at the very, very end, but I don't have a lot of time. So I'm actually going to skip over some slides as we go. And I guess I'll send this. Well, yeah, I guess you do have the presentation in PDF form that you can share Bill, whenever you want. It's public information. So if any people want links and all that stuff, you can just get it from that. And if you want to contact me, there's my contact information, Doug.Kluck at NOAA.gov. Let's just go ahead and get started here. Let me talk a little bit about normals. Every 30 years, we come up with something we call new normals. And the reason for this, there's a lot of reasons for this, but one of the major reasons is it's sort of a worldwide understanding that every nation goes by these quote unquote climate normals and updates them every 10 years actually, but it's a 30-year normal. Now, there are various industries that want these normals at various timescapes. Some of them want the whole period of record, in other words, back to about 1880. But some of them only want the last 30 years. And you can understand that if you're in construction and design and maybe retail, because the climate has changed since the early part of last century, right? And so things aren't the same when it comes to some of these industries and what people kind of care about. And I would say that's probably true for ecosystems to some degree as well. This isn't your grandfather's ecosystem, anymore. Anyway, there are some that want shorter, some that want longer. 30 years is kind of the understood, also from a research point of view, 30 years is sort of the minimum for a lot of statistical review and such as well. Eventually, all these different variables at the bottom of this slide are going to be available. We have temperature and precipitation. That's the easiest two that we have. There'll be other things too. And this is all downloadable. All this data and these data sets and everything else one can grab off of our website, which I can show you later. Let me get into the meat of the matter in terms of comparisons, because I think this will be the most interesting to most of the people on here. And I don't have this part broken down because I don't think it's available yet. It may be, but I don't think it is. Broken down into specific regions. So you're going to get the whole US. And this is comparing the last 30 years, and the last 30 years in our world is 1991 to 2020. So everything's that's our latest 30-year period, okay? And we do this like I said, every 10 years, we adjust it by 10 years and recalculate or recompute those averages and such, and normals, I should say. So on the left, you see precipitation and a % increase in precipitation. And interestingly enough, and you look in the area of this Climate Adaptation Science Center region, there is quite a bit of dark green there, which is a pretty high indication of wetting, if you will, on an annual basis, okay? On the right, you see temperature changes by degrees in Fahrenheit. And again, you see most of the north central part of the US being very trending towards warmer conditions. Now, that is this last 30 years compared to the 20th century. So let's move on. If we just look at the last 30 years compared to the 30 years before that, now think about that. There's 20 years of overlap there, right? So in the end, we're really comparing the 20 teens to the 80s, okay? Because the middle 20 years really doesn't change. That's the same numbers. So here's what's happening, and I think this is pretty fascinating. Yes, you see that wetting signal across the north central part of the U.S. and not the whole area, really in eastern Montana. Now you wouldn't know that today. Well, maybe you would after the snowstorm. But anyway, there's been quite droughty there the last couple of years. But generally, we're seeing wetter conditions in the 20 teens than we did in the 80s in that period, in that area. Now I look at temperature. What's going on with temperature? Well, on an annual basis, Montana, North and South Dakota have actually gotten slightly cooler, and you're going to see that kind of stand out. I'm going to show you seasonal changes too here in just a minute. This is annual. So it's an oddity. Don't ask me to explain it. I'll let Imitaz or somebody like that tell us more about why this is happening. But generally, as a nation, we're getting warmer. Generally, we're getting wetter in some areas and obviously drier in the southwest part of the U.S., which includes Colorado, by the way, and sort of in between when you get out to the central and southern plains. Okay, on we go. So I'm going to have to go fast here. So the next few slides, I'm kind of going to breeze through, and then I got to get to a lot of stuff. So here's the winter, precipitation on the right, temperature on the left. I'm sorry, let's flip that. Precipitation on the left, temperature on the right, and that'll be consistent through the rest of these. But here's the changes between the most recent 30 years and the 30 years before that. So here's the changes that we've seen from the 80s to the 20 teens again. Again, you see that wetness in winter, mainly over the, the north central part of the US, and slightly cooler, but these are average temperatures. And we didn't, we could look at minimums and maximum temperatures too. I think that would be more telling. But average temperatures over that December, January, February period. Look at spring. Look at spring with temperature. Yes, it's a little bit wetter in places and a little bit drier in a few places, but look at the temperature. And we are noticing that, certainly in the last 10 years, that March and April have been cool, just like this year. And let me go back. December has been actually pretty warm. Anyway, March, April, May, mean temperatures, you see a cooling effect, if you will, across the Dakotas and in parts of Montana, and somewhat wetter. And then in summer, again, near normal to slightly cooler in some places, but really not a strong signal, if you will. Now remember, this is only comparing the 80s to the 20 teens. And this isn't necessarily a global warming effect that we're seeing here. This could be more transitory than that. It'll be interesting to see what happens over the next 10 years. Some wetting there in the summer and such. And think about the years that we're including. That's the other thing you can think about. Over a 30-year period, there are some huge years in here in the 20 teens, 2011, 2019, 2018, for that matter. All were pretty darn wet years for this area. So just remember that we're adding those years to the 30 years, and we're taking out the 80s, which were obviously a little bit drier. Let's see, I have fall in here. Yeah, and there's the fall. There we see more warming across the entire region, and still that wet signal across the northern part. All right, so I was going to show you really quick here how monthly differences can matter. This is just looking at temperature. Again, we're looking at 1990 or 91 through 2020, the last 30 years, versus the 30 years before that. So how has it changed? We've gotten cooler in October in the north, got warmer in November across most of the region, and in December, much warmer. Now, somebody please explain that to me, because when I say warmer, I mean warmer than the old normal, by the way. I don't have a theory for that. It just happened. Now, if we go back all the way to the beginning of the last century and look every 30-year period, this is what you see. Okay, so these are 30-year segments looking at the US. I think there's a development of wetness, so you can see that across the central, Midwest, central, and even southern plains through that time period. It's pretty interesting to just look at that. This is just precipitation and changes in precipitation during each of those 30-year periods compared to the entire 20th century. This is the same thing just for temperature. And if you can't see it if you cannot see it in precipitation, you can definitely see it here in temperature in terms of warming across the nation. And it really becoming more and more apparent in the last 30 to 40 years. All right, switching gears. Sorry I had to do this, but I'm going to go through these even faster. What we also do at NCEI is keep track. I don't do this, other people do. But anyway, keep track of billion-dollar disasters. So when there's $1 billion+ of disaster in the country, we mark it down. And so here's some stats. First of all, on the left, this is just looking at U.S. records, heat records. 2021 last year was, look at all the years that have been the warmest. The warmest years are 2012, 2016, 2017, 2021, 2015, and that's even during a La Nina, which is somewhat remarkable. There's some other stats that I put down below this if you want to know. I just wanted to put something a little global in here just to let us know that even though it's cooling in the north central part of the U.S., the world doesn't know it. It is an inconsistent, a paradox. I'll just leave it at that for the moment. I'm sure it will warm up considerably. On the graph on the upper right is billion-dollar disasters that have occurred since 1980, and I'm going to show you a lot more about that in just a few minutes, or a few seconds actually. But notice 2020 and 2021 had two of the highest incidences of billion-dollar disasters in the U.S. All right, so here it is. Here's the graph of all types of disasters, and you can see the kinds of disasters from drought to freezes to severe storms, and each one is colored on here in a bar graph. And the bar graph sort of indicates how many of those occurred each of those years from 1980 to now. All of this is inflation adjusted, by the way, in terms of that line that goes through there. And so we try to keep this as constant as we can. What we see generally are more disasters occurring as we get further and further into the future, and topping $1 billion in terms of damage. Sorry, if you have a $900 million event, it won't make it. The total cost of all these events, something like $2.155 trillion, which is an underestimate, no doubt, because we can't include everything that we should. But this is the closest we can get and keep it simple. Here's 2021. I'm not going to bore you by going through every single one of the disasters that we had last year. But you can see the fires, and you can see the drought, and you can see the severe weather, and golly, all the hurricanes. Hurricanes and tropical storms that we had on the coast. This we also break it down by region. So this is the northern Great Plains region, Montana, Nebraska, North Dakota, South Dakota, Wyoming, Sarley, Colorado. Again, you're in a different region, and we don't break you out in this group, but gives you a flavor for the kinds of disasters that you have seen since 1980 that have reached that threshold of $1 billion. Now, some of this may have been overlapping from a different region into our region, but nevertheless, it still shows that sort of increase in certain types of disasters. And a lot of that is severe storms. There's obviously some flooding mixed in there. You can see 2011 and 2019 prominently in there as well. A little bit of winter storms, but drought, wildfire, all that kind of mixed in there. And the cost there are the lines, the sort of black and red lines indicate the cost per year in terms of billions of dollars of damage. There's just a breakdown by month and the types of disasters you will see in this region: Montana, Nebraska, North and South Dakota, and Wyoming. June is a big month for all disasters. You can see where wildfires tend to crop up, and that's it's becoming year-round, right? But more prevalent from June on. All that makes sense. Same with drought. Okay, I'm going to move on. This is just a disaster frequency sort of, and all this is online. I'm not hiding anything, or there's nothing special about this. I didn't make these. I just pulled them off the web. But I wanted you to let you know that these exist. This is just a frequency of having a disaster in a particular month, or two disasters. That's what the next bar down is. And then the next one is 3+ events. So June is kind of a big month. July can be a big month, etc.
Hey, Doug, let me give you a 2-minute warning, okay? Thanks.
Great. Yep. I'm going to go through this. I'm not even going to go through this. This is all online. If you want the details on costs and cost per year and all that business, it's all there. And this is all broken down by region. This is the number of sort of disasters by time frame, the 80s, 90s, 2000s, etc. And now I'm going to show you something really quick here. We have also got these disasters down to the county level. Now I want you to take just a second or 10 seconds to see that we have a hazard risk bar up at the top, and there's a social vulnerability angle to this as well. So you can look at the hazard. In this case, drought, flooding, and wildfire were chosen. And some of these counties that are darker are really under the gun, if you will, when it comes to the hazard risk for whatever reason. All right. This information has been compiled from FEMA, And I think it's South Carolina University has a really great program in determining the social vulnerability. Here's the social vulnerability chart with all of the disasters kind of thrown together. And you can look at your counties where you are. And I'm going to show you what happens if you click on them. And I'm not going to go into the explanation because I don't have time. But what I'll say is those darker counties have more social vulnerability than the lighter ones for various reasons. And you can go look at that up on there. Here's a couple counties that I just picked, not quite randomly. I picked some of the darker ones, to be honest. Actually, Muscle Shoals is one of the lighter ones, and Oglala Lakota County was one of the darker social vulnerability ones. And you might see where the risk is elevated there compared to the state that they exist in, the county, and the US as a whole. So when you click on that map I just showed you, which is online with all the counties, you'll get this. Okay. And there's just more information where that information came from. Just very quickly, I think Bill wanted a little bit about current conditions. I'm going to show you the drought outlook from the end of last month. Brown is bad, yellow is getting worse. Brown basically means it's not going to change. If you're in drought, you're going to stay in drought. Now, I can imagine some of this getting whittled back over the north, portions of the North Dakota anyway, over the next few weeks, but we'll see. We can hope. Here's the outlook for the summer. It ain't good. Sorry. I hope it's not right. You know, temperature on the left showing a strong probability with a bullseye over Colorado for being above normal.
And the Colorado River Basin that's not
very
positive for them.
Very good point. Yeah, we'll call it a four corners heat dome. There is a possibility though, if you look at the map on the right, you see that even though they're above normal temperatures, there may be sort of equal chances of above or below normal in terms of precipitation. So the possibility of a good monsoon is there. Not that it's going to save anybody. It may save a few folks, but I'm just saying the monsoon looks to be active this year. The plains are under the gun, big time this year. There it is. There's the current drought as of last Thursday, or Tuesday actually. The drought conditions in the Missouri Basin, and sorry for all those areas I left out, but I just wanted to show you the Missouri Basin as a whole because it's really hurting pretty bad. And if you know the reservoir systems, you'll know that as well. Here's the change from last year about this time. So yellow is worse, green is better. And I think that's all I have. Yep, that's all I have today. Sorry to take so long, Bill. And I can't hear you.
Save your questions for Doug for our Q&A period. And golly, I don't know what to think. It's getting warmer and wetter, and it's going to be a hot summer out here, perhaps, if the CPC forecast pans out. Thanks a lot, Doug.